we'll go ahead and go over those. Today's lesson is on fractions and decimals, specifically looking at some word problems with fractions and decimals. But to get you guys warmed up, we had this first question where you were to fill in the different boxes with decimals and fractions. This first one here, what did you get?
0.1.
Mm-hmm. I'm curious how you figured that out.
Because you looked at the front, like 0.2, 0.3.
Mm-hmm. So figure it out,
Yeah, that's 0.1.
the pattern. Is there another way we could have gotten this?
From the fraction.
What could you do with the fraction to get the decimal?
You just put, like, you know how, okay, so my teacher, I remember 6th grade, it was like, you know, there's T and T from the cartoon. It says that you can switch it to a 10. It says 10, hundreds, thousands.
So you're using place value.
Yeah.
We learned a way in developmental math. Do you remember how you can get from a fraction to a decimal? What we could do with the fraction?
That's correct.
Different question. Yesterday we learned this line here can mean something. It can mean a fraction or it can mean division. So you could figure out the decimal by doing 1 divided by 10. And when you do that, you get 0.1. What about this next one? What fraction would go there?
2.10. Wait a minute.
Not 2.10, but 2 tenths. You can write 2 tenths, and that's correct. Is there a different answer you could have had here?
1/5.
Nice. How did you get 1/5?
Because 2 and 10 can divide equally by 2.
Yep. We can divide both of these by 2, simplify the fraction, and get 1/5. This one here, what decimal is that?
0.5.
Yep. If there's one fraction decimal you have memorized, I would make it this one. It's good to know that a half is the same thing as 0.5. But the same way as over here, you could divide to get that decimal, or you could just use the pattern here. 0.7? Yep, 7 tenths. And then this one here?
0.8.
Yep. So we've got that. And then the second part was having you compare fractions and decimals. Ooh, let me erase that first. The first one, for all of these, actually, you're using our inequality signs we learned yesterday, or that equal sign to compare them. So I've got 0.45, 0.8. What inequality sign would I want to put right here?
Less than?
Nice. Now this was a question, there's something similar to this on the final for developmental math, and a lot of students missed it. How did you figure out that a less than sign should go there?
Because you can add a 0 into it, because 45, you can make a 0.
And I saw that on your paper, I was hoping you'd say that. We can make it 0.80. It helps if they've got the same amount of digits after the decimal point, so you can see it's 45 and 80, not 45 and 8. I think this is the next one on your paper, right? 1/6, 2/3. What inequality sign do I want?
I think 1/6 is bigger than 2/3. I don't know.
Tell me why you're thinking that.
I don't
You
know.
don't know?
I just think because the 6 is bigger than the 3. That's why.
Because
why I think. Yeah.
if we're looking at these and we've got like no clue which one's bigger, what could we do to help us out?
Maybe denominator the same.
Ooh, that's not what I was thinking, but that's absolutely a strategy. I've got 1/6 here. You would make the denominators the same. What would this be if we make it have the same denominator?
Oh, shit.
You didn't get that right? 2/3. If we want to make it have the same denominator.
2 would be 6. That's gonna 2 times 2 is gonna be 4.
I hear you saying 3 times 2 would give me 6, so I'm going to do the same thing on top. That gives me 4/6. So we got 1/6. Instead of thinking 2/3, we could think 4/6. And I just heard you say, oh, yeah. So I love that idea. That's not even what I was thinking of, is we can make the denominators the same. Do you know what I was thinking of? What do I just love doing when I have fractions? It was where we started last quarter. Our very first lesson on fractions. What were we doing? not simplifying. I think fractions, if you're trying to compare which one's larger, which one's smaller, it's easier to do if you've got a picture, if you've got a model with it. If I wanted to draw 1/6, what would I do?
Make a circle and up high.
Yep, I'll put it up here. What am I doing with my circle?
Oh, you split.
Divide it into 6 pieces.
Yep.
Picture with-
What's important about my 6 pieces?
They're equal.
Nice. So I will do the best I can. That's pretty good. And how do I make it 1/6?
So you should just shade one.
Yeah. All right. How does that help me out?
So to make sure that how many pieces you got left, right?
Mhm.
Or, well,
So I can see the
how many-
1/6.
Like how many you ate? Like
hmm
five.
What should I do over here?
You just shade 4 more, right? Or you just draw another one.
I'm going to draw another one because this is a separate fraction. When I draw my second circle, something like that?
No, that
Nice. I hear you saying bigger and I'm hearing you say they got to be the same size. Okay. Again, the best I can do. What do you want me to do there?
Do the same thing, 6 with 6 of them, right?
So you're looking down here at the 4/6. We don't even necessarily need that. We could do it with 2/3 if we want. I volunteered myself to draw thirds.
Then you
Kinda.
shade 2.
Shade 1, 2. How does having those pictures help me?
To let you know who ate the most pie. I guess.
We're sticking with the pie. Who ate the most pie based on those pictures?
2/3.
Yeah, we've got more of it colored in, so you could also go back to pictures. The last strategy we learned with that is just compare them to 1/2 in your head, especially if you guys are already thinking like pies and pizzas. You ate 1 out of the 6 slices. Did you eat a half a pizza? No, we ate less. If you ate 2 out of the 3 slices of pizza, did you eat half?
more than half.
You ate more than half. So comparing them to a half, drawing pictures, making the denominators the same, all great strategies to use. This last one here, I gave you a fraction and a decimal. If we wanted to compare those, there's something I'd probably want to do first.
You can just change half to a 0.5 or below 0.
Why is that helpful, changing it to a decimal?
To let you know which one's bigger than the other one.
Yeah. It puts them in the same form. So I would say change this one to a decimal or change this one to a fraction, but we want them in the same form to be able to compare them. Once we do that, we could add a 0, and then someone from this table,
Less than.
yeah. I'm realizing now I made them all less than. That's probably not the best thing on my part, but you guys did a great job comparing. Are we feeling warmed up with some fractions and decimals? Ready to do some word problems? Our favorite thing? I will go ahead and get us started. The lesson today, like I said, is we're going to be doing all the things. We're going to be adding, subtracting, multiplying, and dividing with fractions and decimals. And we're going to be using those 4 operations to help us answer word problems. I'm looking at word problems so that we can focus and get practice with word problems, but also focus and get practice just with doing the math. Similar to yesterday, this is going to be reviewing a lot of stuff you learned in developmental math. We're just doing it all at once. So the first ones we're going to look at are some word problems with fractions. Our first example says Rachel rode her bike for 1/5 of a mile on Monday and 2/5 of a mile on Tuesday. The first part of the question is asking how many miles did she ride altogether? Tell me what you're thinking we want to do for that first part.
So 1/4. You just write 1/4.
1/4.
Oh,
One.
1/5.
You're good. So write 1/5.
Yes, and the other one is 2/5.
2/5. So let's put down some fractions.
Yeah.
I hear you saying add. Why do we want to add them?
Because in the question said how many miles does she write all together?
Mm-hmm. So what's that key word they're telling you we want to add?
All together.
I agree. We're trying to find the total. We're trying to put stuff together we want to add. Now this is a review of how we're adding fractions. What would I want to do in order to add those fractions together?
Straight across.
So when you say straight across, you want me to add?
1
1 plus 2,
Mhm.
that's gonna be 3.
Mhm.
5 plus 5 is gonna be 10, right?
We agree?
Or does that have to stay the same?
We're questioning ourselves. Or does what have to stay the same?
The 5 more.
So we're trying to figure out, do we want 5 there or 10?
We could like the whole total that she right for miles, right? So it'd be 5 plus 5 would be 10, right? Altogether, you know.
Do we have ideas over here?
Actually, it's supposed to be like 5.
Can you explain why?
You're not supposed to change the denominator.
We're not supposed to change the denominator? Well, you know what I'm going to say? Same as that last problem. Let's go back to some pictures and just real quickly think about this with pictures. Instead of circles, circles are hard for me to draw, so I'm going to draw a rectangle instead. We've got 1/5. So if this represents like the road, a mile-long road. So she's gone 1/5 of the mile. And then the next day she's gone 2/5. So I'm adding the two parts together, right? So I've got, here's the 1/5. And then 2/5 would be how many?
Also, it's still the same then. Oh,
Yeah.
okay.
This part here is our 1/5. This part here is the 2/5. So I hear you saying, oh, it's going to stay the same. It's just going to be
Just to show the
3/5 of the mile. When you are adding or subtracting fractions, what Io said is true. That denominator, I like how you're using that math vocab, that denominator is going to stay the same. So if you were not sure about that or you were thinking it should be a 10, let's write down a note. We're going to write when you add or subtract, the denominator stays the same. That's the note I'm writing for myself. If you think of it differently, if you want to write a different note, you can. But anytime we add or subtract fractions, that denominator is going to be the same. Now, what if they weren't the same here? What if I had like 1/5 and 2/15?
You have to figure out how
Yeah,
to do the same.
Yep, I hear Francis saying we got to make them the same. I got to figure out that. That might be what comes next. The second part of our question, though, says, on Wednesday, she rode 1/2 of a mile. If she does that every day for 4 days, how far did she ride her bike? What are we thinking for the second part here?
So it's gonna be 1/2 of a mile.
1/2 of a mile.
And it says 4 days, every day for 4 days. And she said how far did she ride her bike, so it's gonna be addition, right?
Addition of what?
1/4 plus 4 days. Right?
1/2.
There's multiplication.
So I'm hearing adding here. I'm hearing multiplication here.
She rode it for 4 days, so she's going to multiply the half and more times 4.
Like that. Could we write this with addition?
Because she's telling that every day for 4
Yeah.
days.
So what would the addition problem look like?
1/2 plus 1/2 plus 1/2 plus 1/2.
Uh-huh. Are they going to give you the same answer?
And then 4 was it?
Well, the thing is, it's gonna multiplication like 1/2 times 4, so it's gonna put like more decimals, right?
Well, let's do both. You give me both options. I heard you say this one here is, I already heard you say 4/2. Tell me how you got that.
Just this, like how the numerator together.
Say it one more time.
This 1 plus 1.
Oh, you're looking down here?
Yeah.
So you said similar to what we did up here, 1 plus 1 plus 1 plus 1 gives you 4/2. How do we multiply fractions? Here's a review of
The
multiplying.
numerator with the whole number.
So what would that look like?
4/1.
4/1. So that first step is changing it to look like a fraction. And then here I'm multiplying,
This straight.
going straight across. So 1 times 4,
So
2 times 1, 2. Does it matter which way you think of it? Nope. Now I would say if instead of saying for 4 days, I said 40 days, do you have a preference then?
No, I just put time for it to make it
Yeah.
easier.
I would say multiply. If this number gets big, I probably don't want to write this 40 times, which is why it's good to know both ways. But if I said like 2 days or 3 days, I think both ways work. Now for both of these, we've got 4 halves. Is that my final answer?
Well, no. Because of the, I think the 4 is too big.
I hear simplifying, I hear the 4's bigger, which is a sign you can simplify. How would I simplify this?
Because you can divide like 2
Yep.
divided by 4.
Divide by 2. Final answer now?
Too big. So.
How would you read that fraction?
2 is 1 or something like that. 2 whole, I don't know.
You're getting closer. I heard 2 1s, which doesn't sound right. And then you said 2 wholes, which I like.
2 over 1.
2 wholes. What is 2 wholes?
Like full. It's like full. It's like
Yeah.
full like a 5 type thing.
Full as in it's not a fraction anymore. It's
just a number.
it's just a 2. So in this problem, we're reviewing a lot of things. One of the things I wanted to see is, do we remember how to multiply fractions? Now I would say the process to multiplying fractions is different than adding. Do you see what's different about these things?
The denominator goes in on the addition and not the multiplication.
Yeah. In order to multiply, did we need to make those denominators the same? No. So you could write a note for yourself like that. You could say the denominators, I wish this word was shorter. The denominators don't need to be the same. So that's one thing I was reviewing is in order to multiply, you don't need those denominators to be the same. You guys immediately caught simplifying this, which is great. This part right here is something sometimes students forget to do, is that they just leave it as like 2 over 1 or 2 wholes, however you think of it. If that denominator is 1, we don't need it. Because like you said, it's a whole thing. It's not a fraction anymore. One of the mistakes I saw when we were doing this lesson last quarter is this. Are these the same thing? Who can tell me why?
1/2 of it.
Yeah, this is 1/2. 1/2 is not the same thing as 2. You have half a pizza, that is not the same thing as 2 pizzas. But 2 whole pizzas is the same thing as 2 pizzas. So if you're changing it to the number 2, where does the 1 need to be?
Be gone.
Yeah, it does go away. But where does the 1 in the fraction need to be?
Under the 2.
Which we call
The
denominator.
denominator.
Yep. My final answer for this one, what's the question asking for?
How
Miles.
far does she
Which one?
live?
Yep.
Miles.
Yeah, I like how you went to the miles. So our final answer, I'm not going to write it, but we would say 2 miles. How are we feeling on these? Good review? Okay. There are, I think on the next page, 2 questions for you to try. Go ahead and give you, let's take like a minute and a half to try those 2. And then we'll get some answers. Where? Let's start with part A. Can I have a volunteer come up and do part A? You're gonna do it? Yay! I don't think you came to the board yesterday too, so this is perfect. I'm going to have you pause right there real quick and tell us what you're thinking.
When you say James needs to walk 7/10 of a kilometer to school, he has already walked 3/10 of a kilometer. How much further does he need to walk? So you're going to subtract this from this. So
Love it.
you can also simplify your answer.
Ooh. And you could always be a teacher too if you want and call on them. He says no. Nice. Do we agree? We got questions for Teacher Ayo? Nope. All right. What about part B? I saw we weren't a big fan of part B.
I get confused because he
You wanna-
mentioned like where you know how he started walking. That's why I got confused.
So let's do it together. You're going to be our writer?
Yeah.
If you get stuck, you remember, my favorite thing about being at the board is you can just turn around and ask the class, what do you guys think? So for this one, let's start putting.
After school, Jake had to walk out to stop by this bookstore. The bookstore is 1/5 of a kilometer from school. So after this 7:10, that is the normal kilometer of the school. So you walk another 1/5. So what is the total distance? So we are adding the 7/10 with the 1/5.
Now that 7/10, that 7/10 is
7/10.
is the other fraction you had to find. So I want you to say one more time, why are we adding 7/10? You're right. You're right, but just say it one more time.
Because 7/10 is the total distance of the school to the school from his house.
Yeah.
So this 1/5 is the extra distance he walked to the bookstore.
Yeah. If we drew, I'm going to have you stay right there, but I'm just going to draw a picture to go with it. He's starting, not with this marker. He is starting, I got it, at his house. And what's the first thing he's doing?
He needs to walk 7/10.
So he's walking to the school. And you've told me he's walking, hand obey. He's walking 7/10 of a mile. And then what is he doing?
And after school, he went
Went to the bookstore.
And that is, so the question's asking for what?
What is the total distance Jake will walk after going to the bookstore?
Yeah. So we want to find the total distance of him going to school and the bookstore. So for this second part here, you had to pull some of the information from up here. So you're going to take over now. You're going to do the addition.
So
Love it. Turn around, ask them.
are you gonna do straight or what do we do?
Also divide, 5 times 2 would be 10, then after 1 times 2 would be 2.
So 5 times 2.
Yeah.
One
It has to
times
be the same as the 10.
What has to be the same?
The 5, what's that called? I forgot the name.
What's it called?
Denominator.
Yeah, the denominator.
Yeah. That would be 2 tenths.
Nice. Is that my final answer?
And add 7 tenths.
Yeah.
That's gonna be 9 tenths.
My board is too short for you. 9 tenths. Love it. 9 tenths what?
Of a mile.
9. Whoop, wait. I said, yeah. I was like, nice. Wait. Yep. 9 tenths of a kilometer. Nice. How are we feeling on that one? Better now? Awesome. That was a hard one to come to the board. Thank you so much. I'm going to have you hold on to it just in case you come up again. All right. We've got one more fraction one we're going to look at, and then we'll move on to some decimals. This last fraction one. Okay. This last fraction one says there was 5/8 of a pie left in the fridge. Daniel ate 1/4 of the leftover pie. How much of the pie did he have? And this one here, what are we starting off with?
So the total of the pie was left in the refrigerator was 5/8.
So he's starting with 5/8. And what is he doing?
So Daniel ate 1/4 of it.
1/4 of what?
Of the leftover pie.
So he ate 1/4 of
The 5/8.
the leftover pie. So I'm just writing down what you're saying. He's starting off with this, and he ate 1/4 of this.
So you're saying that how much did he have? Like he ate.
Yep. So looking,
So you can draw like a big circle and split 4, right? No.
do you want to go with a picture? Okay, so I'm going to draw what he's starting off with.
Yes.
Why do I keep drawing circles?
It's a pie, right?
It is. Okay, wait, this one isn't too bad to draw. Okay. So I've got 8, so he's got 1, 2, 3, 4, 5/8. And he's eating
1/4.
a fourth. Is that easy to draw 1/4 of 5 slices?
You can go to draw another one and just split 4. Right?
Draw another one.
Oh no.
I can't change the amount he has though, so I can't switch over to 4. Some of these problems you can definitely do with a picture. Like if he had 4/8 of a pie, it would be easy to see what one of that 4 is. But because the numbers aren't as nice, we're going to have to do some math instead. I've written it like this for a reason. If you were trying to find a fraction of something, what type of math is that describing?
So the 4 has to be the same with the 8, right? So no.
Let's figure out first what type of math it is. Because if it's addition, it does. What are you saying?
Division?
Not division.
Subtraction.
Not subtraction. This word of right here?
38.
Nope. That word of, it's the only one you haven't said. Multiplication. If you are finding a fraction of something, you are multiplying. You are multiplying 1/4 times 5/8. It's similar to when we were finding like percentages of something last quarter. We were multiplying there. Fractions of something, it's the same idea. I think the biggest mistake with these problems is students want to subtract. So they say, okay, he's starting with this. He ate 1/4. Let's take that away. Let's see what's left over. There's something specific about how it's written. It doesn't say he ate 1/4 the pie. It says he ate 1/4 of the leftover pie. He's not eating 1/4 of a pie. He's eating 1/4 of this. And those mean different things. Once we know it's multiplication, I think you guys are pretty good at taking over here. What would I want to do? Get the denominators the same?
No, you want to just multiply straight across.
For multiplying, do we need the denominators to be the same? What if we did make them the same? Is that wrong? If we don't know, let's try it. So you're saying we want to multiply straight across. If you do make the denominators the same, what would it look like?
2 8.
Times
5/8.
5/8. Let's do both. So here, which one do we want to start with, I guess? The first one? Okay. So here, if I'm multiplying, what do I get?
5/32.
5/32 of a pie. And then the second one?
So it'd be 10/8.
We're
You have to
multiplying.
multiply it all together? Oh,
Yeah.
okay, so 10,
72.
Wait a minute.
Not 72.
64.
Mm-hmm. Now they look different. Are they different?
Yeah, but they're going to equal out to the same thing when you simplify it, so it'll be 5 over by 32s.
Yeah, how do we simplify this?
Divide it by 2.
Yep. And you're already saying it's going to give us 5. Did you divide this or you just knew it was going to be the same? If you divide this.
Divide it into is going to be 32.
Yep. And so we get the same. So I asked earlier, is this, if you do make the denominators the same, is it wrong? Could you? You could make them I can't talk. Could you make the denominators the same?
Yes.
Yeah, it'll give you the same answer. Is it necessary?
No.
No. It's just making the numbers larger. So if you're thinking you want to do that, you can. There's nothing wrong with it, but you're going to end up with the same answer at the end. So I'm trying to save you time here. We get 5 30-seconds. What word would I want to put after that? 5 30-seconds.
Left on the pie.
Yeah, I'm just going to say of a pie, but you could say of a pie he ate. He ate 5 30-seconds of a pie, something like that. How are you feeling on this one? Okay. There's one last one. This is a you choose your adventure. There are 2 options here. You are going to choose one and give me a short little story to go with it. Before you start, we had something similar to this with integers last quarter where I gave you some negative numbers and asked you to tell a story. And the mistake students were making with that one was they were picking stories of something that can't be negative. So for example, with the negative one, someone was saying, oh, there were -5 people in this group, but you can't have -5 people. So when you go to write your story for this, you have to pick something that can be a fraction. So I can't write a story about how 5/6 of a person does this and 1/2 of a person does this because you can't have fractions with people. So pick something that can be a fraction amount. Okay?
So I have to write a whole word problem?
Yeah, just like a short, it doesn't have to be an elaborate story, but just like a short little word problem. And you can choose which one you want. So you can choose the multiplication one or the subtraction one.
I'm not good at this, but I'll try.
I'm a math teacher. I'm not a storyteller either, but you can do this. I'm very excited to see the stories. You're going distances left. If you're stuck, let's think of some things that can be a fraction. What are some things you can use fractions to describe? So I said like people, we can't write a story about people. But what are some things we have seen fractions with in real?
Miles.
What did you say?
Miles. Kilometers.
Kilometers. Mm-hmm. So like a distance. So you could write a story about going a distance. What are some other things? Give me one more thing we could write a story about. So like with food, yeah, I see fractions a lot in the kitchen when I'm cooking. You've got like measuring cups that are fractions. So use one of those 2 things to inspire you. Can I come peek at what you have? Mm-hmm. Which one are you going with? This.
For this one.
I agree.
It's hard to think about it somewhere else.
Mm-hmm. So which one are you going off of?
I'm going with A.
It might, if you're looking at the multiplication one, it might help to think of,
No, never mind. I'll go with this one.
okay. So then you might want to think of like what we were saying up here. Ooh, I love how you're using that word there. Nice. Yep, you got it. Now just give me what the answer is. But at this point, it sounds like that's going to be the easy part. You already walked. Mm-hmm. Yeah. No, I like everything you're doing. That is not our final answer.
I'm at 30.
Everything is good up to that point, but there's one more thing you can do. I noticed you're all picking the subtraction problem. So I'm going to get one story for this one, and then I think there's a way to edit what you guys said just a little bit for this one here. For the subtraction one, who's real proud of their story, wants to share it? You don't know? You can be proud. I don't think so. You'll share it? Okay, tell us what you got.
Layla grew a total of 5/6 of a foot over a year. Michaela grew a half a foot in a year. What's the difference in their height?
Love it. So you've got Layla grew 5/6 of a foot. And then who's the other one?
Michaela.
M-I-K-H.
A-I-L-A.
I don't know why I can't do this. M-I-K-H.
A-I.
A-I-L-A. Okay, thank you. And Michaela grew half a foot. And I love how she's using that word difference. She's asking what is the difference in what they grew, which would be a subtraction problem. Since you all did the subtraction, tell me what we ended up getting.
1/3.
1/3. So in this problem, it would be 1/3 of a foot. Both of you wrote real similar stories about like walking a distance. So you've got someone's walking 5/6 of, I think it was like a kilometer or a mile. We could change that just a little bit to be a multiplication problem. If we've got, I'm going to use you. If we've got Io walked 5/6, what did you use? Kilometers? 5 miles? So we've got you walked 5/6 of a mile on Monday. Remember, when you're multiplying a fraction, it's the same thing as finding half of this fraction. So we could say I walked 5/6 of a mile on Monday. He walked, I could say half of that, or half of that distance, something like that. So we'll say half of that distance today. What would my question be?
5/6 times 1/3 and 1/2.
What would the word part be?
Right. He walked 1/2 of the distance.
Mm-hmm. So this, I haven't asked a question yet. I'm just giving information. What would the question part be?
like the,
Distance.
What about the distance? So for example, you told me Layla grew this much, Michaela grew this much, and then your question was, what is the difference
Right.
in their height? For the multiplication problem, if I said this information, what would that question part be?
How much did he walk altogether?
If I asked all together, what type of problem would it be?
was it how total all the distance?
If I asked how much he walked total, that's what type of math?
But that's multiplication,
Nope. If I'm asking for a total, that's addition. What would this find you? Not the total. Let me break it down into smaller questions. How far did he walk Monday?
5, 6.
5/6 of a mile. It says he walked 5/6 on Monday. How far did he walk today?
The one half of it. Of the distance.
Did he walk? I hear
he's
the.
splitting the 5, 6, like how you call it?
Yeah.
He's splitting
Mhm.
5, 6 of it, like half of it.
Yeah. So the question, what would we find by doing this?
Division.
What information would we find in this problem by doing this? I heard you go, oh.
Oh no, I forgot already.
We
And
know-
The only clue that gives me is of the distance.
Yeah. So we don't know. It's saying he walked half of that. We don't know how far he walked today. We just know it's half of this. It's not saying he walked half a mile. It's saying I'm giving you some information about what he walked today.
Is it,
I'm not asking for math. I'm saying what would the word problem be? What would the question be I'm asking here? We know how far he walked Monday. Do we know how far he walked today? I see you shaking your head no. The question would be, how far did he walk today? You can find how far he walked today by taking half of 1/6 by doing this math here. You just were going ahead and doing the math. We're going to leave the fractions. The second part of this is decimals, which I think students...
How did you do this last one?
This one?
Yeah.
I got that from Francis. You want to read your question one more time? I didn't write everything on the board.
Layla grew a total of 5/6 of a foot over a year. Michaela grew a half a foot in a year. What's the difference in their height?
So she was saying that subtraction problem you could use to find the difference in their height. What you've got is also good. So you could also find like the difference in a distance. I was just trying to get one example for each. We're going to go on to some decimals. The example I've got says Brenda and Jenna together saved $12.75 last week and $8 this week to buy a gift for Mother's Day. They're planning in advance because Mother's Day is not nearby. The gift they want to buy costs $17.50. Do the sisters have enough money for the gift? I see some of you are already doing math. Tell me what you're thinking we need to do here.
Like, so they saved that $12.25 last week, and like this week they're gonna save $8, so it's gonna be like what? Like $20 and 75 cents.
How'd you do that?
So easy.
It's so easy. Share it with me. What are you doing to get that?
So last week they already saved $12.75.
Mm-hmm.
And this week they earned $8.
Mm-hmm.
Yes, and so it's gonna be all total of the money because they went to the store. So
Mhm.
it's like how much they're gonna pay for that present.
Mm-hmm. So I hear you saying total. What type of math do I want to do?
And
Add. I'm adding $12.75 and
$8.
8.
Nope,
What's wrong with that?
because it has to be, there needs to be 2 decimals after the 8, so it needs to be 8.
Yeah. What does it mean if I put the 8 there?
That's just 8 cents.
Yeah. So if I wanted to summarize what we're doing here, you said there needs to be 2 zeros after the decimal point. Why is that?
To make it $8.
Why do we need to write it like this?
Because that's 75 cents.
Because you have to know that at decimal point.
But why? I've heard because we need to make it $8, we need two numbers after the decimal point.
I just got $8.
Yeah. You're adding the $12 with the $8. We need to add the whole numbers together and then add
75 cents.
the decimal parts or the cents together, right? Francis said if I put the 8 here, that's like cents. And 8 isn't cents, it's $8. We're adding the whole numbers together and the decimals together. When you are adding or subtracting decimals, we need those decimal points to line up like that. And I already heard you say the answer. You said,
$1.25.
what did we just figure out?
They have enough money for the
Yeah, this is their money, so we figured out they have enough money. So do the sisters have enough money for the gift? We can say, yes. You know, I love asking you guys to like justify or explain. If I had asked that, what could we say?
You take 2075 and you would subtract it by 1750, that would give them $3.25 left over.
Ooh, yeah. So you're going ahead above and beyond and saying like, yeah, they've got enough money. They would have this much money left over. You could just justify by saying this is how much money they have. This is how much money they need. They've got enough. Or you could go that extra step and say like, well, I can even tell you how much money they have left over after doing that. Part B says, if the sisters want to split the cost of the gift, how much should each pay?
divide by 2.
Why are we dividing by 2?
There's 2 sisters.
There's 2 sisters.
Dividing 1750 by 2.
And we're splitting the cost, which is division. And you went ahead and you told me what we're dividing by 2. You said the 1750. Why are we dividing this and not this?
So that's the 1750 is the cost of the gift and not the 2075.
Yeah. This right here is our gift. The 2075 is,
The total what they got.
yeah, their total money. So we're splitting the cost of the gift by the 2 sisters. So we're doing 1750. I'm going to write it like this, divided by 2. Look, how fun, long division. How am I going to do that?
2 goes into 17 8 times.
Mm-hmm. So my 8 goes here.
I think it's $7.50. No, wait, $8.50. No, 25 cents.
Let's keep going. So you said 2 goes into 17 8 times. I heard 16.
Let's try to be 1.
Mhm. So we get a remainder of 1.
Bring down to 5.
Mm-hmm.
It would be 7.
Mm-hmm. 2.
15 7 times.
Probably.
Yep. 87.
Never. The decimal,
Yep.
8 and 7.
Thank you. So 2 goes into 15 7 times,
14.
which is 14. Oh
1.
no. 1.
Bring down to 0.
Mm-hmm.
And then we're going to there 5 times.
Yep. 2 goes into our 10 5 times. So we're left with,
$5.
Why did you make it 15?
say it one more time.
Why did you make it 15? But that's my point.
Because you're bringing down.
Yeah.
That 5 came down.
Oh, okay.
I wrote the decimal point there, but you don't really need it since you're asking yourself how many 2 go into 15. Each time you're putting the numbers together. How do we feel about that one? I think from memory, there's one last part, right? Yeah, part C. And part B is back up here. Part C says, Brenda also wants to buy 5 chocolate bars for their mom. Each chocolate bar costs 95 cents. How much total money does she need for the chocolate? Tell me what we're thinking here.
So 0.95 times 5 pieces of chocolate.
Times the 5 pieces of chocolate. Where do you want my 5 this time?
Just the 5, right under the 5.
Yeah. So what's different about multiplying decimals?
Yeah, you know how they got the bases? I remember this one teacher,
Mhm.
sixth grade, it's like 1, 2, and you just press just a dot, I guess,
Mhm.
something like that. Or
Yep.
you can just add the 0 under the 9 or the dot.
So what I hear you saying is how we're going to get the answer. Just the way I've set this multiplication problem up, how is this different from what we did with the adding and subtracting?
Cause you're going, when you go over this one, you're gonna go over two, going straight down.
Let me ask a different question. If I wanted to add 95 cents with 5, would I write it the same way? What would I write?
9.5, right?
If I wanted to add 95 cents plus 5, how would I write that? Yeah, the decimals. So when you're adding or subtracting decimals, those decimal points need to line up. Notice for this multiplication problem, you guys didn't tell me do that. You said we don't have to do that. You guys just so badly want to give me the answer. That's what you both kept saying is, oh, you got to do this. When we multiply this, tell me what did you get?
Well, 5 times 5 is 25, right?
Mm-hmm.
With the 2, so it's 45, so that's going to be 47.
Mm-hmm.
Yeah, so 0 times 5 would be 0, that would be 4.
Mm-hmm.
Dot, $4.75.
Yeah. So how much total money does she need? $4.75. How are you feeling about decimals?
Pretty good.
Are your brains tired? They look a little tired. The good news is there's just one last practice one for the lesson. So if you go down to that bottom part, I think it's similar to this where there's like 2 or 3 parts to the question. But that'll be the last thing we've got. It's similar to this last problem where it builds on some of the previous parts. So if you want me to check it after you finish part A and then finish part B, I can do that with the pen in my pocket.
Which one are we doing?
You're doing that practice one. So number 2, the one about Becca riding her bike. Goodbye.